Hello to you. I'm Jesse Johnson. This is NEAR, N-E-A-R, NEAR perpetual machines or semi-perpetual machines. This is a proof of concept. NEAR perpetual machines or semi-perpetual machines can be made, even though a straight perpetual machine cannot be made. This does not remove the fact of a NEAR or semi-perpetual machine being made, which is an actual machine that lasts a long time, in human lifetime terms that is, that uses 1/100th to 1/1000th of some of the energy and or force being made by the machine itself to run itself, needing no external energy and or force to continue running, while giving large amounts of work and or energy and or force in return. Consider this: hydroelectric power. This is being used as a simplicity. Water falls from A down in direction B and accumulates at C. The amount of force it took to make the water fall from A to C is approximately the amount of force it takes to take this water from C back up to A. As the water falls in direction B, it turns turbine fan blades. The turbine is coupled to an electric generator which produces electricity. In other words, how do you get the water from C back up to A using 1/100th to 1/1000th the energy and or force? Consider this: a solid dead weight representing the water falls from A to C. As it falls, it's coupled to an electric generator which produces electricity. Now, how do you get the dead weight from C back up to A so it may fall again repeatedly? Consider this once again using permanent magnets only. Permanent magnets only. 1. Permanent magnet number 1 is able to lift 1,000 pounds, a distance of 1½ inches. Permanent magnet number 1 has 2,000 pounds of lifting strength. Number 2. Permanent magnet number 1 is attached to a 1,000 pounds dead weight. 3. Permanent magnet number 1 lifts dead weight 1½ inches to the bottom of a metal plate and holds it there. 4. Now, disattach permanent magnet number 1 from the plate. It will take 1,500 to 2,000 pounds of force to do so. Now, 5. How do you disattach permanent magnet number 1 using only 1 ounce to 1 pound of force from the plate, instead of 1,500 to 2,000 pounds of force to do so? 6. The metal plate is of an exact length, exact width, and exact thickness to be able to do this. 7. This allows a permanent magnet number 2 of the same dimensions and strength as permanent magnet number 1 to be slid over the top of the plate over permanent magnet number 1. 8. Permanent magnet number 1 and number 2 are repelling each other, south-south or north-north. With the same amount of force, they're attracted to the metal plate along the same lines of force. In other words, the forces are equal, E-Q-U-A-L, equal, but opposite directed, such that the forces cancels each other out to 0. Number 9. When done precise, it takes about 1 ounce to 1 pound of force to disattach the 2,000 pounds of permanent magnet number 1's attraction force to the metal plate. Excuse me just for a second, please. Now, let's continue. Now, I'm going to show you a very simple thing I made. This is to show this simple principle of breaking the force of one magnet by another. Hold on, please. I'm going to move the camera.
Jesse, what's going on, man?
How you doing, fella?
Good. How about you, man?
Not bad at all. Hold on a second, please. Now, let's continue. This little wood stand is a control stand. It is to control the few movements of the small magnets that I'll be using. The magnets are attached to the metal, but are repelling each other. Now, this here is on repulsion. These little magnets right here are on repulsion. And I'm going to take a feeler gauge or a spark plug gap blade and put it here. Spark plug gap blade, put it there. Put it there. And take this one, which is repelling, and I put an R right here, repelling. Now, the first thing I'll do is lift this set of magnets all the way up until it attaches to the metal right here. There we go. It's attached to the metal. Okay, here we go. I'll put it in straight. Okay. Now, I'm going to take this magnet, put it here, and slide it over these magnets. Slide it over those magnets. And let's see what takes place. Exactly. There. You see it fall? Did you see it fall? I'll do it again. I will do it again, so you may see it. Pick this magnets up, let them stick. Okay, they're stuck there. And push these magnets over those exactingly, as exact as I can get it. There it goes once again. Now, I'm going to do this with less magnets to show you. Okay. Take this feeler gauge, or better yet, this spark plug gap blade. Put it here. Straighten that out. Put it there. Oh. Got to put one of these. Okay, got to put one of these. Let it fall. Put the blade in. Okay, little metal piece right here. Metal blade. Now bring this magnet up. Bring it up until it sticks to the metal blade itself. Metal. There we go. Okay, here we go. Now, I'm going to take this one. This is repelling, and slide it over the other magnet, such that there it goes. There it goes. This is to show now. This is to observe whether the magnet, whether the bottom magnet under the metal will fall when the top magnets are brought or slid exactly above it. This is a very simple experiment. For this means that no matter how powerful the attraction force of magnets are of the force of attachment to the metal, it can be broken with the repulsion force repulsion force of another magnet sliding above it that has the same strength and the same size. 5, when done with precision, way more precision than you see here, much more precision than you see here. That means if it's done with precision machine makeup, it will take 1 ounce to 1 pound of force to break a traction attachment of any magnet. Whether those magnets are attracting with a force of 5 pounds of force to the metal, or 50 tons of force or more to the metal. What's to be done is to have the metal plate and permanent magnet number 2 step up 1.5 inch independently. Once you get the magnet like this, like that, you step the little thing up, one more step up, then have this magnet here, stick under it, then bring this one, slide it over, make it drop again, then bring it up again, then keep on doing it, up again, then pull permanent magnet number 2 back out of the way. You pull this magnet back out of the way when you step it up so that the other magnet can stick up under it. Then you bring it again and make it fall. Then you step it up a little more. Then you pull that out of the way, let it fall, let it stick. Then pull this one across, make it fall, then step it up again, bring this back, let it stick again, then bring this one over, then let it fall, then keep on going up, 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 and up until you get to A again, from C to A. You pull permanent magnet number 2 back out of the way, then let permanent magnet number 1 attract to the metal plate again, and repeat over and over again until you get from C to A. Now I'm going to move the camera. Hold on, please. Now I would like to thank everyone for listening and watching. Please share this video of semi-perpetual machines and have quite a good day. Oh yes, for all of my videos, write Jesse Johnson. That's Jesse. Jesse Johnson into YouTube. You will see my image in a circle with deep green trees as background. Click that image. It will take you to the home page. Then click videos. I want to thank everyone again for listening and watching, and have a very good day.